AI moved fast again today, and if you blinked, you missed 3 headlines. This is Tech Roundup on the AI Verge, your daily dose of what actually matters in AI minus the hype. Let's get into it.
We usually think of the tech industry, especially at that trillion-dollar tier, as this highly polished, just incredibly strategic machine.
Right, like everything is planned out years in advance.
Exactly. You expect these meticulously planned product roadmaps. A massive tech giant spends billions on research. They host a flashy, overproduced keynote, and then they release this sleek piece of hardware with their logo stamped on it. It's supposed to be clean. It's supposed to be predictable.
Yeah, but that is definitely not what's happening right now.
No, not at all. Because looking at the landscape our trackers are highlighting this week, that entire polished corporate illusion is just completely breaking down. We are watching this decentralized, chaotic free-for-all right now.
Oh, 100%. It's a scramble.
Yeah, you have this mysterious, nameless, totally ownerless AI model just dropping out of the sky on a random Friday. And it's immediately trading blows with the most expensive models on Earth. And then, at the exact same time, those massive tech giants are literally fighting each other in bankruptcy court, bidding millions of dollars over the decades-old corporate emails of a failed airline.
Which is just wild to watch unfold.
Right. It feels like the industry is scrambling, not strategizing.
I mean, the word I would use is definitely scrambling, yes. But it is a highly calculated scramble, and it's driven by absolute necessity. We're basically watching the traditional moats around these massive companies just evaporate in real time.
Evaporate how, exactly?
Yeah.
Because they still have all the money.
They have the money, sure, but the infrastructure required to build at the frontier, it's hitting these massive physical and informational walls. So what looks like chaos from the outside, anonymous models, the weird bankruptcy data auctions, it's actually the industry desperately trying to route around these massive structural bottlenecks. It's a fundamental paradigm shift in how artificial intelligence is sourced, how it's built, and how it's deployed.
Which is exactly why we're diving straight into it for this weekend's deep dive on the AI Verge. We are breaking down what our sources show as the absolute most critical developments of the week. But I have to be honest, I'm looking at this outline, and my immediate practical filter is just kicking in hard.
You're skeptical.
I am highly skeptical that a mystery model with no owner isn't just another flash in the pan. I mean, we see shiny new toys every single week. And more importantly, I am really struggling to understand how a tech giant buying the digital scrap heap of a bankrupt airline actually helps a normal user get their work done on a Monday morning. It feels like these labs are just totally losing the plot.
Well, the plot is actually tightening, believe it or not. And the connection between those bankrupt airline emails and your Monday morning workflow is actually incredibly direct.
I'll believe it when I hear it.
There is a massive structural reason for all of this. What we are seeing is the sheer technical scale of the data and compute squeeze happening behind the scenes. We're going to break down the mechanics of these massive tectonic shifts, how they are forcing the market to adapt, and, why the software tools you rely on are about to fundamentally change under the hood.
Okay, well, if you are looking to actually understand the mechanics of what's happening at the frontier of tech, and more importantly, how you can leverage it before your competitors do, make sure you hit subscribe on the AI Verge so you never miss these fast-paced weekend roundups. Let's jump straight into the first major macro story we are tracking, because it is, without a doubt, the most bizarre data gold rush I've ever seen.
Yeah, this one is fascinating.
So, Spirit Airlines officially went out of business back in May. We all know that.
Yeah.
Rival airlines immediately swooped in to buy up their physical assets, right? Their airport terminal slots, their gates, their actual physical planes.
Which makes perfect sense for an airline.
Exactly. That makes total logical sense for the aviation industry. But our sources are tracking a completely different kind of auction happening alongside it. The tech companies aren't bidding on planes. They're bidding millions of dollars on internal corporate records dating all the way back to 1986.
Because the physical planes are arguably the least valuable thing Spirit Airlines left behind.
Wait, really?
Oh, absolutely. The tech giants, they want the internal paperwork.
But look at the sheer volume of what is in this data trove, though. Our trackers show this includes 100 million internal emails, 500 million Microsoft Teams messages, 7.5 billion anonymized transaction records, along with decades of internal spreadsheets, project timelines, logistical workflows.
It's massive.
It is. And notably, our sources say this does not include any external customer data or credit card info. This is purely internal chatter. And Google just won the initial auction on Friday with a $10 million bid.
Right. But then it got interesting.
Yeah, then an AI startup called Micro One submitted a late bid for $12.5 million. Another player, Mercer, threw in a bid for $7.5 million.
Yeah.
And I have to apply some friction here. Spirit Airlines literally failed. They went bankrupt.
They did.
Their internal processes clearly did not result in a sustainable business. So why on earth would Google or anyone else want to train a cutting-edge, future-facing artificial intelligence on the internal workflows of a company that crashed and burned? Are these AI labs just scraping the absolute bottom of the data barrel because they've run out of internet to read?
I mean, it seems completely counterintuitive to buy the playbook of a losing team, right? But the value here isn't in the business strategy itself. It is in the raw, unpolished mechanics of human friction.
Human friction.
Yeah. This is about acquiring something called workflow data. To understand why this is such a goldmine, you really have to look at how AI models are currently trained. Up until now, the diet of a frontier model has basically been the public internet. Wikipedia, Reddit, published blogs, news articles, digitized books.
Which is pretty much everything.
It's a lot, yeah. And that kind of training data teaches a neural network how to speak, how to structure a sentence, and how to recall general facts. But the public internet is essentially a finished product. It's people publishing their final thoughts. It does not teach a model how to actually do work.
Okay, so if I'm understanding this correctly, reading a Wikipedia article about supply chain logistics tells the AI what a supply chain is, but it doesn't show the AI how to handle a warehouse manager screaming in a Microsoft Teams channel because the shipment of parts is stuck in customs.
That is exactly the perfect distinction. The internet is declarative knowledge. Workflow data is procedural knowledge. AI labs are desperate for immense written records of how large, complex enterprises actually function day to day.
Because it's never as clean as a Wikipedia article.
Never. A 1986 email chain about rerouting a flight, or a messy Microsoft Teams thread from 2023 where 5 different departments are arguing over a scheduling conflict, that is a pure record of human problem solving. It shows an employee encountering a bizarre edge case, asking a manager for help, routing a ticket, referencing a company policy, debating a workaround, and finally resolving an issue.
Even if the resolution took 3 days and 40 emails.
Exactly. That multi-step, multi-agent human decision-making is the holy grail for training the next generation of enterprise AI.
So the AI doesn't actually care that Spirit Airlines went bankrupt. It just cares that for 30 years, thousands of human beings were typing out the step-by-step logic of how to solve logistical nightmares in real time.
The bankruptcy is completely irrelevant to the training data. The model is just learning the syntax of corporate action. And, this data is incredibly rare. You cannot scrape internal company Slack channels off a public website. That data is locked behind corporate firewalls.
Okay, but wait. If these labs are so desperate for this kind of data, why don't they just use their current models to generate it? We hear about synthetic data all the time, right?
Right.
Where an AI is basically prompted to talk to another AI to generate millions of fake conversations to train on. Wouldn't that be cheaper than spending $12.5 million on a dead airline's emails?
You'd think so, but synthetic data has a massive limitation, and it's something the whole industry is colliding with right now. When AI talks to AI to generate a fake corporate workflow, it tends to be way too clean.
Like, too logical.
Yeah, exactly. The simulated problem gets resolved perfectly in 2 steps. It lacks the messy, unpredictable, irrational nuances of a real human enterprise environment. Synthetic data doesn't naturally replicate the friction of someone forgetting to attach a file, or a manager misinterpreting a policy, or a third-party vendor just dropping off the grid for 3 days.
Right, the stuff that actually ruins your Monday.
Exactly. If you want to build an AI agent that can operate inside a real Fortune 500 company, you have to train it on the chaotic reality of how those companies actually operate. Spirit Airlines provides decades of that exact chaos.
That makes total sense from a technical standpoint, but honestly, it serves as a massive warning for anyone listening to this deep dive. Think about your own day-to-day work. Your current corporate Slack channels, your mundane Teams messages, those endless, annoying back and forths trying to schedule a meeting or fix a bug in a spreadsheet.
You are generating procedural knowledge.
Yes, your digital exhaust might literally be the training data for tomorrow's enterprise AI agents, which is mildly terrifying, but it certainly explains the $12.5 million late bid.
It really proves that high-quality human-generated data is becoming the ultimate bottleneck in AI development right now.
But data's only half the equation, right? Because if data is the first bottleneck, hardware is definitely the second. At the exact same time these companies are fighting over corporate emails, Our sources show they are getting aggressively squeezed by the hardware manufacturers, specifically Nvidia.
Oh, the compute squeeze is very real. And the physics of hardware manufacturing are starting to aggressively dictate the software market. Nvidia is actively warning their enterprise clients of a price hike of over 15% on their AI servers shipping in 2027.
15%.
Yeah, and we're talking about the upcoming Vera Rubin and Grace Blackwell systems, which are the massive supercomputers that train these frontier models.
And our trackers note that Nvidia is essentially joining companies like Amazon and Apple in passing these rising supply chain costs directly onto the customer.
Hmm.
But a 15% hike on enterprise-grade server racks that already cost millions of dollars, that's an astronomical increase in capital expenditure for any lab trying to build or run a frontier model.
It is.
I know there's a lot of hardware jargon here, but what is the physical reason for this bottleneck? Why can't they just make the servers cheaper?
So the constraint here isn't actually the computing power like the processing chips themselves. The massive bottleneck is something called high bandwidth memory, or HBM. To understand why this matters, you really have to look at how an AI model actually functions on a hardware level. A large language model is essentially a giant mathematical matrix. When you send it a prompt, the server has to pull trillions of parameters out of its memory and feed them into the processor to actually do the math to predict the next word.
Okay, so if the processor's the engine of a car, the memory is the fuel line feeding it gasoline.
That's a great way to put it.
Right.
And right now, the engine is massive, but the fuel line is way too narrow. This is known in computer science as the von Neumann bottleneck. You can have the fastest processor in the entire world, but if it takes too long to fetch the data from the memory, the processor just sits there idle. It's wasting energy.
So they have to make the fuel line bigger.
Right. And to solve this for AI, hardware engineers developed high bandwidth memory. Instead of putting the memory chips far away from the processor on the motherboard, they physically stack the memory chips on top of each other, layer by layer, and place them microscopic distances from the processor.
Which I imagine requires incredibly precise, complex manufacturing.
Extremely complex. It requires manufacturing capabilities that are currently just maxed out globally. The foundries simply cannot manufacture HBM chips fast enough or stack them perfectly enough to keep up with the demand from AI labs. Because supply is constrained and demand is infinite, the cost of these memory chips is skyrocketing.
And Nvidia isn't just going to eat that cost.
No, Nvidia is protecting its own gross profit margins by taking that increased memory cost and passing it directly to the buyers of the finished servers.
So we have this scenario where the raw data needed to train the models is becoming scarce and expensive, and the physical memory chips needed to run the models are becoming scarce and expensive.
That's the reality.
My practical takeaway from this is purely economic. If compute and memory are getting this expensive, the current business model of the AI industry, which is, relying exclusively on massive, bloated, trillion-parameter models for everything, it's completely unsustainable for most normal businesses.
Yeah.
You cannot have a mid-sized marketing firm paying top dollar to access a supercomputer just to draft a cold outreach email or a sort of messy spreadsheet. The math simply does not work.
The math is breaking. And that breaking point is driving the single biggest pivot we've seen in the software landscape this year. The market is violently pivoting away from the giants and towards smaller, highly specialized models. The economic moat that companies like OpenAI and Google thought they had is evaporating, literally because the rising hardware costs are forcing developers to seek efficiency over pure power.
Let's follow that logic right into our next major update, because the data we are seeing on this small model rebellion is absolutely staggering. According to our trackers analyzing the Vercel platform, which is a massive deployment environment for developers building AI apps, the share of tokens processed by open-source models rocketed from 28% to 62% in just 2 months.
It's a massive swing.
That is a violent shift away from the proprietary closed-source giants. Developers are voting with their wallets.
It is a complete inversion of the market hierarchy, and the mechanism driving this is a backlash against what the developer community calls token maxing. For the past year, the default behavior for anyone building an AI tool was to just throw the biggest, smartest, most expensive API at every single problem.
Because it was easy.
Exactly. If you needed to extract a date from a receipt, you used a multi-trillion parameter model. If you needed to translate a single sentence, you used a multi-trillion parameter model.
Which, using your car analogy, is like using a massive, fuel-chugging semi-truck to deliver a single pizza across town. I mean, it works, but it's a massive waste of resources.
It is entirely inefficient. And as those API costs add up, enterprises are realizing they can't afford to run their businesses on a fleet of semi-trucks. They need a fleet of highly efficient bicycles.
Well, let's look at the specific case study in our sources that
Yeah.
proves this out,
Yeah.
because this is honestly the first time I've been genuinely impressed by the small model ecosystem. A marketing and behavioral insights firm called NexLM just unveiled a specialized system they are calling Savant 3.5.
Oh, this is a masterclass in specialized
They
architecture.
didn't build a model from scratch. They took an existing open source foundation, the Nvidia Nemotron models, and they purpose-built it for one hyper-specific business task: finding sales prospects. This isn't a generalist bot that can write poetry or code in Python. It literally just finds buyers.
Right.
Now, our sources note it's technically a 30 billion parameter model, but it only uses 3 billion active parameters per input. How does a model that have 30 billion parameters but only use 3 billion to do the actual work?
That is a technique called mixture of experts, or MOE, and it is the key to this whole new wave of efficiency. Instead of building one giant brain where every single neuron fires every time you ask it a question, you build a model made up of several smaller, specialized expert networks. When you send a prompt into the model, a router looks at the prompt and decides which specific expert is best equipped to handle it.
So it's kind of like a hospital. You have a massive building with hundreds of doctors. That's your 30 billion total parameters. But if a patient comes in with a broken arm, you don't page the cardiologist, the neurologist, and the oncologist. You only page the orthopedic surgeon.
Yes.
So the hospital has massive capacity, but only a small fraction of the staff is active for any given patient.
That is a brilliant way to conceptualize it. The model routes the query to the specific 3 billion parameter subnetwork that handles that type of logic. This means the model requires significantly less compute power and less high bandwidth memory to run, making it blisteringly fast and incredibly cheap.
And the results they got by specializing this way are shocking. They didn't just compete with the frontier models, they crushed them. Let's look at the exact numbers from our sources here. The benchmark NexLM used was highly practical. How many actual eventual buyers appeared in the top 10% of a model's recommendations?
A real business metric.
Exactly. NexLM's specialized Savant model put 24.6% of buyers in that top tier. OpenAI's massive GPT-5.6 Sol only managed 22.8%. Grok 4.5 was at 22.3%, and Anthropic's models were entirely out of their depth, with Opus 5 ranking dead last at 14.6%.
The theoretical limits of generalization are really being exposed here. A model that is trained to do everything is naturally going to be slightly worse at hyper-specific tasks than a model engineered solely for that one task.
But the cost delta is what turns this from an interesting academic exercise into a massive business threat to the giants. Savant achieved that superior hit rate for a fraction of a cent. Specifically, our trackers show it costs between 0.003 and 0.01 of one toes per 1,000 prospects scored. Meanwhile, running that exact same volume through the frontier API giants costs anywhere from 26 cents to over $5.
It's not even close. You were talking about a scenario where the specialized open weight model is performing the task measurably better and doing it for literal pennies compared to dollars. That economic reality changes the entire infrastructure of the internet.
It also changes the security reality, which I think is huge. For me, the most compelling part of the Savant 3.5 story is that a business can run this 3 billion active parameter model locally on their own internal hardware. You do not have to package up your most critical proprietary customer data and beam it up to a massive cloud provider's API.
Which is a huge selling point for enterprise.
Right. You retain total data sovereignty, it costs almost nothing to run, and it outperforms the trillion-dollar labs. If your model isn't specifically tuned to your internal business outcomes, you are just renting generalized intelligence at a massive premium.
And trust me, the major cloud providers are watching this exact dynamic play out, and it is triggering a full-blown panic in their pricing departments. The moat is breached, and they are reacting by slashing prices.
The pricing war is escalating incredibly fast right now. Our trackers show that OpenAI just slashed their GPT-5.6 Sol API pricing by over 20%, and they locked that discount in for 3 months. That is a highly aggressive temporary price cut designed solely to stop developers from migrating their workflows to cheaper open source alternatives.
It's a defensive move.
Totally defensive. And the cannibalization is happening inside these companies too. Within Anthropic's own ecosystem, our sources show that their cheaper, smaller model Opus 5 actually overtook their massive premium model, Fable 5, in corporate spending within a single month of its launch.
Because developers are getting smarter. The driving force behind that internal cannibalization is the rise of intelligent routing systems. Companies are getting incredibly sophisticated about their software architecture. They aren't just picking one model anymore. They are deploying API gateways that act like a triage nurse.
So, returning to the hospital analogy, the software itself decides how sick the patient is before assigning a doctor.
Precisely. If a user asks the application a simple question like, summarize this paragraph or extract the total amount from this PDF invoice, the gateway routes that prompt to a cheap, fast model like Opus 5 or even a local open source model. It only escalates the prompt to the massive, expensive Fable 5 model if the task requires deep, multi-step logical reasoning like, analyze this 50-page legal contract and find the contradictory indemnity clauses. Enterprises are basically refusing to pay Fable 5 prices for Opus 5 work.
The switching costs are effectively zero now. Developers can swap the underlying intelligence of their apps with a few lines of code. But, and this is a big but, it's not just these highly specialized small models putting pressure on the giants. We have to address the absolute wild card that dropped onto the scene this weekend. Let's talk about the mystery model.
Oh man, this is arguably the most disruptive event of the month.
A stealth model named Ox Alpha just appeared completely anonymously on OpenRadar. There is no lab name attached, no press release, no launch video, just a massive, highly capable model dropped onto a public platform offering a 1.05 million token context window, a 131,000 token output limit, and a staggering capacity for 100 trillion tokens per day.
Those numbers are insane.
And right now, the creator is letting anyone use it entirely for free.
Right, and to contextualize those numbers for a listener who might not be deep into the engineering side, those are not hobbyist specifications. A 1.05 million token context window means you can upload several entire textbooks or the entire code base of a massive software application into the model's short-term memory all at once.
Which is huge for developers.
Massive. And a 131,000 token output limit is virtually unheard of. Most commercial models stop generating text after a few thousand words. A 131K output means this model can generate a small novel or write a massive interconnected software module in a single unbroken response.
It is clearly built for intense, sustained agentic work and long-horizon software development. I mean, it even takes text, image, and video inputs natively. And according to the early benchmarks we are tracking, it is not just big, it is incredibly smart. It hit 63% on the full testing for the deep SWE coding evaluations. That score puts it right up there, trading blows with Anthropic's Fable 5 and OpenAI's GPT-5.6 all. Even Patrick Collison, the CEO of Stripe, publicly called it very impressive.
The performance is undeniable.
But here is where my practical skepticism goes into absolute overdrive. It is a shiny new toy, it is incredibly powerful, but has no owner. Who is looking at your data?
The absolute lack of provenance is the most dangerous part of this deployment.
The creator posted a brief note claiming that prompts and outputs aren't currently being used for training, but they also noted that policies can change overnight. I have to put a massive red flag on this for anyone listening. Do not put your proprietary company code, your financial spreadsheets, or your secure customer information into an anonymous, free model on the internet, no matter how high its coding benchmark is.
It's just not worth the risk.
We have zero idea who built this infrastructure, what country the servers are located in, or where that data is being stored.
The security risk is massive, which is exactly why the entire developer community is playing forensic detective right now, trying to reverse engineer its origins based on how it behaves. The speculation is fascinating. Some analysts are looking at the exceptional coding scores and the Chinese zodiac naming convention Ox Alpha and speculating that it's a stealth release from a major Chinese lab.
Like who?
They are pointing to Z.AI's GLM6 or potentially their GLM 5.3 flash model.
And there is historical precedent for that. Our sources note that the last 4 anonymous high-performance drops on OpenRouter over the past 6 months have all eventually been traced back to Chinese labs.
Right, but then there's another camp of researchers who look at the multimodal capabilities, the way it natively handles video and massive context windows, and they think it might be the next generation of Google's Gemini being shadow-tested in the wild, or perhaps a new iteration of Microsoft's MAI models.
Regardless of who built it, the geopolitical and market implications of a foreign lab or a rogue team casually dropping a frontier-level coding model for free are just destabilizing. If it turns out this is a highly efficient, smaller parameter model capable of flash-level speeds and it's hitting near-frontier coding benchmarks, it completely shatters the Silicon Valley illusion.
It really does.
The narrative has always been that only 3 or 4 American tech giants with infinite compute budgets can play in this arena. Ox Alpha proves that the technological moat is shrinking incredibly fast.
And the giants are acutely aware that their generalized intelligence is being commoditized by open weights and mystery models. Their strategic response is to carve out highly defended, hyper-specific niches where trust and security are paramount.
Which brings us nicely to Anthropic's latest move. Since we are on the topic of security and coding, let's look at how Anthropic is trying to build a new kind of moat. Our trackers show they are taking their most powerful, capable model, Claude Mythos 5, and they are releasing a specialized version strictly for cybersecurity defense, operating under the banner of Claude Security.
This is a masterstroke in structural software design. They are addressing the exact security fears you just highlighted with Ox Alpha.
The implementation here is fascinating. They are widening access to this immensely powerful model for enterprise customers, but they are doing it in a way that structurally prevents bad actors from weaponizing it. If I understand our sources correctly, they are deploying it without actually letting anyone prompt the model directly. How do you even use an AI if you can't type a prompt into it?
So the underlying mechanism there is restriction of the interface. Recent frontier models have demonstrated a pretty shocking capability. They aren't just good at reading code and finding security vulnerabilities. They are actually capable of writing the specific malicious code needed to exploit those vulnerabilities.
Right.
If you give a bad actor, or even just a curious employee, direct conversational access to a model as smart as Mythos 5, you have essentially handed them a master key to break into enterprise networks.
You are giving them a highly competent cyber criminal in a chat box.
Exactly the risk. So Anthropic's solution is to remove the chat box entirely. If you are an enterprise cybersecurity defender using their approved partner tools, the Claude Security model operates in the background. It will automatically scan your company's codebase, identify the vulnerabilities, and output the suggested patches or alerts to fix the weakness. But the human user has no text interface to interact with the model. You cannot type, "Hey Claude, write me an exploit for this weakness." The model's architecture only permits defensive outputs.
So it's essentially a one-way mirror. The AI can look at your code and hand you a shield, but you can't ask it to build you a sword.
That's a great analogy.
I think that is a very practical, grounded way to deploy frontier intelligence safely inside a corporation.
But it also highlights the massive capital required to engineer these security protocols, run the specialized routing we talked about earlier, and buy the hyper-expensive Nvidia hardware. Let's quickly run through the rapid-fire business shakeups our sources are tracking, because the sheer amount of money moving around the board right now is dizzying.
The valuations are completely detaching from traditional software metrics. Hugging Face, which is the central hub hosting millions of these open-source models and datasets, is reportedly exploring massive M&A deals that would value the company at $13 billion. That's nearly triple their valuation from their funding round in late 2023. Then you have Anthropic, who we just discussed. They are reportedly eyeing an eye-watering $100 billion valuation for a potential IPO. But the most telling detail in our sources is their recent executive hire. They just brought on the former Google TPU chief, Amir Salek, to lead a project to build their own in-house AI chips.
Which is huge.
It connects perfectly back to the macro bottleneck we discussed at the top of the show. They are trying to escape the Nvidia compute squeeze by vertically integrating their own hardware stack.
The logic there is pure survival. If your entire business relies on Nvidia's hardware, you are entirely at the mercy of their supply chains and their 15% price hikes. If you can successfully design and fabricate your own custom silicon, you control your own destiny. But, and it's a big but, building chips takes years and billions in capital expenditure.
Meanwhile, as Anthropic tries to expand into hardware, Apple seems to be contracting. Our sources indicate Apple is cutting over 200 jobs from their Vision Pro and Siri teams. It looks like a massive reallocation of internal resources as they struggle to find their footing and define their consumer strategy in this rapidly shifting AI race.
The market volatility is incredible right now. The underlying hardware layer is becoming prohibitively expensive. The middle layer of open-weight models is becoming ruthlessly competitive, and the massive consumer applications are still desperately searching for solid ground.
Okay, let's pivot away from the macro corporate drama, the billions of dollars, and the hardware shortages. I want to look at some of the actual tech, the specialized tools, and the agent updates crossing our desks this week. Because setting the corporate warfare aside, there are a few technological breakouts here that are genuinely fascinating and push the boundaries of what these systems can actually do in the physical world. Let's start with biological AI.
This one is wild.
A startup called Outer Bio just emerged from stealth. And the detail that caught everyone's attention is that it was co-founded by Lady Gaga.
The celebrity aspect definitely gets the headline, but the intersection of biological computing and machine learning happening at this startup is one of the most exciting developments in the field right now.
What they are doing sounds like science fiction. They've built a platform called Una. The process starts by taking donated, full-thickness human skin tissue. They place this living tissue onto a highly complex 3D printed scaffold. This scaffold is engineered to act like a surrogate body. It constantly feeds the tissue nutrients and clears away cellular waste, effectively keeping the skin alive in a lab environment for 4 straight weeks.
The duration is the massive breakthrough there. Historically, in vitro lab skin degrades and dies in about 5 to 7 days. You simply cannot run meaningful long-term dermatological or pharmaceutical tests on a biological sample that degrades that quickly. The latency of traditional drug discovery is severely bottlenecked by this physical limitation.
Right. So because the Una platform keeps the tissue viable for a month, they can run extensive, prolonged experiments on how the living skin responds to various new skincare compounds and chemicals. Yeah. But here is where the AI integration happens. They take all of that complex biological response data, how the cells react, the inflammation markers, the absorption rates, and they feed it into a proprietary machine learning model.
The feedback loop.
Exactly. The AI analyzes this massive data set of biological interactions and uses it to predict which entirely new chemical compounds will be viable for future treatments. And because this is a closed loop, every physical test they run on the scaffold generates more data, which sharpens the AI's next set of predictions. According to our sources, this closed-loop system cut their compound discovery time from 18 months down to just 6 weeks. They already have 6 active leads for new treatments in development.
The implications of that feedback loop are profound. The traditional pharmaceutical and cosmetic testing pipeline is painfully slow, incredibly expensive, and heavily reliant on animal testing or very limited human trials. By successfully digitizing the biological response of living human tissue, the AI can simulate millions of molecular interactions in a computer and only output the top 10 compounds that actually have a statistical biological probability of working. It drastically shrinks the search space for new drugs and treatments. It's a massive leap forward for translating digital AI into physical world applications.
I will absolutely acknowledge that it is a brilliant engineering feat. The hardware of the scaffold, combined with the software of the AI, is a great closed-loop system. Yeah. But I have to provide the practical biological skeptic check here. Living lab skin, even when sustained on an advanced 3D printed scaffold, has major physiological limitations. It has no blood flow. It does not have an active systemic immune system. If you put an irritant on the lab skin, it cannot recruit white blood cells from the rest of a body to respond to the localized inflammation. So while the AI might crunch the numbers and find a compound that works perfectly on isolated scaffolded tissue, it is still only a partial simulation of how a complete, complex human being will actually react. It is a phenomenal filtering tool to find potential candidates quickly, but it does not replace the final critical hurdle of real human clinical testing.
That is a very grounded reality check. Yeah. The AI is optimizing for a simplified biological environment. It's a rapid prototyping tool for biology, not a final clinical trial. But speaking of tools that are evolving to operate with more autonomy and less human intervention, we need to transition to the software agent breakouts happening this week, because the architecture of how AI software executes tasks is leveling up incredibly fast.
Let's look at a startup called Inherent. It was founded by a group of former DeepMind alumni, and they just built an AI teammate they're calling Faraday. What stood out to me in our trackers is that they didn't use a massive model. They used a tiny 27 billion parameter model.
Tiny being relative, of course.
Right, but relative to the giants, it's tiny. Yet this small model is actively outperforming massive trillion parameter models from Anthropic and OpenAI at a highly complex, rigorous task, replicating and validating the results of scientific research papers.
And that data point ties right back to our earlier discussion about the small model rebellion. Highly specialized architecture beats generalized brute force. But the real breakthrough with Faraday and systems like it isn't just the underlying language model itself, it is the complex software architecture built around it. We are seeing a massive evolution in what developers call the agent harness.
I want to break down that concept for the listener, because an AI model by itself, just the raw neural network, is basically just a brain floating in a jar, right? It can't think, but it can't act.
That's the perfect analogy. Early language models, like the very first iterations of ChatGPT, relied solely on predicting the next word in a sequence. They were isolated brains. They couldn't do anything in the real world. They couldn't browse the live web. They couldn't click a button on a website. They couldn't write and execute Python code. They were entirely useless without a harness. A harness is a software environment built around the model that acts as its nervous system and its hands, allowing it to interact with external digital tools and APIs.
So the harness takes the AI's generated text and translates it into physical actions on a computer.
Exactly. And what our sources are tracking right now, particularly with deployments like SpaceX AI's Grokbot, is that these harnesses are evolving from simple tools into 247 multi-agent ecosystems. Grokbot is now being integrated across platforms like SuperGrok Plus and Cursor, and the key shift is that it is no longer just one single bot trying to do everything. The harness allows you to assign explicit ownership to different specialized agents.
What does that look like in practice?
You can spin up an agent and explicitly define its role as a sales prospector. You spin up another and define it as a website builder. You create a third and assign it as an inbox manager.
But how do they not just spiral out of control? I know how these models hallucinate. If you leave 3 AI bots alone to talk to each other, how do they not end up stuck in an infinite loop of generating nonsense?
The mechanism preventing that is the implementation of governed boundaries and typed handoffs within the harness. You don't just give the bot a prompt, you give it a specific, reusable skill and a rigid verification routine. So the sales prospector bot is instructed to scour LinkedIn for leads. But before it can do anything else, it must verify the lead against a strict set of rules. Does this person match our target industry? Are they a decision maker?
So it has to check its own work.
Right. Once the bot verifies the lead, it executes a typed handoff to the inbox manager bot. The inbox bot receives the verified data, drafts the email, and stages it for human approval. The breakthrough here is that the harness manages the flow of state between the bots. They can hand off tasks, verify each other's work, and correct errors without constant human babysitting. It turns a single AI model into a specialized assembly line.
That sounds incredibly efficient in theory, but my practical filter is screaming again. I know how messy real corporate workflows are. Systems break, passwords change, APIs fail. One broken connection in that multi-agent chain, and the whole automated assembly line grinds to a halt. Still, the fact that we are moving away from typing single prompts into a chat box and moving toward deploying autonomous multi-agent teams that run in the background is a monumental shift in how we interact with computers.
It's the beginning of a new era for software.
All right, we are going to transition into the second half of our deep dive. We are stepping away from the macro industry news, the billion-dollar valuations, and the theoretical agents. We want to get highly practical. For the rest of the show, we are going to walk you through 2 specific actionable AI productivity workflows that you can actually set up, test, and use this weekend.
These aren't theoretical concepts. This is the tactical stuff you can literally deploy on Monday morning to save yourself hours of manual labor.
But before we get into the step-by-step guides, if you are finding value in this breakdown and you want to ensure you stay ahead of these rapid technological shifts, make sure you hit subscribe on the AI Verge channel. We do this every single weekend, filtering out the noise and bringing you the exact developments and workflows you need to know about. All right, weekend workflow number 1, the Gemini Canvas dashboard.
I love the utility of this workflow. It solves a universal, painful problem that almost every professional deals with.
The core problem is staring at messy, ugly, chaotic spreadsheets. We all have them, whether for work or personal life. Budget trackers, sales pipelines, project timelines, content calendars, inventory lists. You find yourself staring at hundreds of rows of raw text and numbers, and you struggle to make any narrative sense of the data, especially when you need to present it in a Monday morning status meeting.
It's overwhelming.
It is. You need to visualize the data to understand the trends, but building custom charts, pivot tables, and dynamic graphs in Excel or Google Sheets can take hours if you aren't a dedicated power user.
And that friction is exactly what this workflow eliminates. The setup is incredibly lightweight. All you need is a Google Sheet populated with your raw, messy data, and you need Google Gemini opened in a separate tab in your web browser. That is the entire setup.
Walk us through the exact mechanical steps. How do we turn a wall of text into something visually presentable without spending an hour clicking through spreadsheet menus?
It genuinely takes less than a minute. You go into your Gemini browser tab. Next to the main text input bar where you normally type your prompt, there is a small plus button. You click that and you select the option for Canvas. This fundamentally changes the interface, opening up a split-screen workspace where the AI can write code and render visuals side by side with your chat.
Okay, got the split screen, then what?
Now, your prompt needs to be direct and specific about where the data lives. You pipe, make me an interactive dashboard using the data from tabs 1 and 2. Assuming your Google Workspace is connected and permitted, Gemini will reach into your Google Drive, read the raw data from those specific spreadsheet tabs, and process it.
What exactly is happening under the hood when it reads that data? Is it just summarizing it in text?
No, it's doing something much more complex. The AI analyzes the data structures. It identifies dates, financial figures, categories, and statuses. It then dynamically generates the underlying code required to build visual charts. And it instantly renders an interactive visual dashboard right there inside the Canvas window. It builds the pie charts, the bar graphs, and the pipeline trackers automatically.
And because this is happening inside the Canvas environment, our sources note that you can interact with it immediately. You can generate a shareable link to that specific Canvas session. You can send that link directly to a coworker or a client, and when they click it, they will see the fully rendered interactive dashboard in their own browser without needing to mess with the raw spreadsheet.
Exactly. It's totally shareable.
Or you can take the workflow a step further. While looking at the dashboard, you can type a follow-up prompt to Gemini saying, convert this dashboard into a presentation deck. The AI will take the visual charts it just generated, format them into individual slides, and instantly export the entire thing to Google Slides, or allow you to download it as a polished PDF for your Monday meeting.
It's magic. Let's ground this with a concrete example use case so listeners can visualize how to apply it. Let's say you are a freight logistics broker. Your daily life is managing dozens of trucking routes, hundreds of driver contacts, active shipping deals, and delayed deliveries. Your raw data in Google Sheets is just a massive, intimidating wall of text and tracking numbers.
A total headache.
Right. In 15 seconds, using this Gemini Canvas workflow, you can turn that chaotic spreadsheet into a clean pipeline visualization that shows you exactly what percentage of your deliveries are delayed, categorized by geographic region, with a bar chart showing which specific trucking companies are causing the bottlenecks. Or, if you are a corporate team leader, you can point it at your department's expense sheet and instantly visualize your Q3 active projects stacked up against the remaining quarterly budgets.
It completely removes the technical barrier to data visualization. You don't need to know how to write a macro or build a pivot table. You just use natural language to demand the visual output you want. Okay, here comes my skeptic check because I have been burned by AI trying to do math and manage spreadsheets before. What if my source spreadsheet is a complete disaster? What if it has missing cells, mismatched date formatting, human data entry errors, or text mixed in with numbers? Does the AI throw a clear error message? Or does it just hallucinate fake numbers to make the graphs look pretty incomplete?
That is the critical vulnerability of this workflow. Yes, silent data loss is a very real, very dangerous problem when using large language models to parse messy, unstructured data arrays. If a row in your spreadsheet is formatted strangely, say, a date is written as a text instead of a numerical value, the AI might not know how to graph it.
So it just skips it.
Instead of pausing and throwing a massive red error message telling you to fix row 42, the model might just silently skip that entire row and render the chart without it. The resulting graphs will look beautiful, colorful, and highly professional, but the underlying data representation will be fundamentally incorrect.
Which means if you present that to your boss, you are presenting false information with immense confidence. So what are the practical guardrails a user must put in place before utilizing this?
The guardrails require manual human verification. You must aggressively spot-check the generated dashboard against your raw data before you share it. Pick 3 or 4 random specific data points from your messy spreadsheet, a specific invoice amount, or a specific delayed project, and manually verify that they are accurately represented in the visual chart the AI generated. And the absolute most important rule: never, ever use an AI-generated dashboard for strict financial auditing, legal compliance reporting, or tax filings without manually auditing the formulas first. The Canvas feature is a rapid prototyping tool designed to help you quickly spot trends and anomalies. It is a visualizer. It is not a certified public accountant.
That is a crucial distinction. It's a tool for discovery, not for definitive auditing. But as a prototyping tool to cure spreadsheet blindness, it is incredibly powerful. So your weekend action challenge for this first workflow is this. Take one chaotic, intimidating spreadsheet in your personal or professional life this weekend. Maybe it's your personal household budget or a side project timeline. Spend exactly 15 minutes loading that sheet into a Gemini Canvas and prompting it to turn it into an interactive dashboard. Force yourself to see how quickly you can prototype a visual tool and see if the charts reveal a trend or a bottleneck that you are completely missing when looking at the raw text.
It is 15 minutes that will fundamentally change how you interact with your own data.
All right, let's move on to weekend workflow number 2. Now, a quick caveat. This specific workflow is currently designed for Mac users, as it relies on specific desktop operating system integrations. We're talking about connecting your iMessages directly inside your ChatGPT interface.
This is a massive unlock for anyone who struggles with contextual fragmentation during their workday.
The core problem this workflow solves is the friction of context switching. Picture your typical deep work setup. You are focused on your primary monitor, deep in a task, writing a proposal, or researching a topic. Your phone is sitting on your desk, and it's buzzing with text messages from clients, family members, or colleagues. Every time it buzzes, you have to break your visual focus, physically pick up the phone, read the text, and process it.
It totally breaks your flow state.
Completely. And worse, if you need to synthesize information, say a client texts you a project detail, and you need to incorporate that detail into the email you are drafting with your AI assistant, you have to copy the text on your phone, paste it somewhere your computer can access it, and then feed it into the AI. It is a disjointed, highly inefficient way to operate.
The setup here integrates those two worlds. It requires a Mac computer running the dedicated ChatGPT work or Codex desktop application, rather than just using the browser version.
Okay, what is the exact mechanical workflow to link your private text messages to this desktop AI app?
Once you have the desktop application open and authenticated, you navigate to the top menu bar. You click on Plugins and then select the public directory. In that directory, you search for a specific plugin called Messages and hit Install. When you install it, the plugin requests permission to connect to the local messages database stored on your Mac's hard drive. Once that connection is established, the workflow is incredibly seamless. All you have to do is invoke the plugin in your normal ChatGPT prompt by typing the @messages tag.
Give me some highly specific examples of how a professional actually uses this integration, because I want to know if it provides real utility or if it's just a parlor trick for tech enthusiasts.
The utility is massive when you combine it with other system integrations. Let's look at schedule management. If you have your calendar connected to your Mac as well, you can open your ChatGPT desktop app and type, "Check my calendar for next week," and reply to John via @messages, providing him with 3 specific times I am free for dinner.
And it just does it.
Yeah, the AI model will execute a multi-step semantic reasoning process. First, it queries your local calendar database to find the open blocks of time. Then, it uses the @messages plugin to search your text history to find the most recent thread with the contact name John. It drafts a contextually appropriate message offering those 3 times, and it stages that drafted message directly in your Mac's iMessage application ready to send.
So it's executing retrieval augmented generation across multiple local databases on your machine. What about administrative tasks? Can it pull information out of the texts?
Absolutely. You can prompt the system with something like, "Scan my messages from the past 30 days, find any mentions of upcoming birthdays or anniversaries, and automatically add those events to my calendar." Or, from a digital hygiene perspective, you can say, "Find any potential spam or automated marketing messages in my messages history that I can safely delete." It essentially turns your entire messy text message history into a highly organized, semantically searchable database.
Okay, my skeptic alarms are absolutely blaring right now. The utility sounds great, but the privacy implications are staggering. You are talking about giving a third-party AI model full programmatic access to your personal text messages. For most people, their iMessage history contains deeply sensitive information, financial discussions with spouses, passwords sent by colleagues, personal health updates, confidential client negotiations. You are essentially letting a plug-in read your private life. How is that data being handled?
Your alarm bells should absolutely be ringing, and this is not a workflow to enable blindly without understanding the architecture. The practical guardrails here are non-negotiable. First, you must strictly manage the plugin permissions on an as-needed basis. Do not leave the Messages plugin toggled on all the time. Only enable it when you actively need it to perform a specific search or drafting task, and then immediately disable the permission afterward.
That makes sense. Treat it like a temporary bridge.
Exactly. Second, and this is the most critical behavioral change, you must always manually check what context the AI has pulled before you hit send on any drafted text. The AI will stage the drafted message in your app, but you must be the final human approval layer. Third, you have to understand where the processing is happening. When you ask the AI to summarize a sensitive conversation, the text of that conversation is being pulled from your local Mac database and sent to the cloud to be processed by the language model. You must be hyper aware of what data you are willing to send to external servers.
Honestly, for my personal daily use, the massive privacy trade-off of sending my text history to the cloud might not be worth the convenience of saving a few seconds of copy-pasting. But if you are a real estate agent or a contractor or someone managing a massive volume of client texts on a dedicated, strictly professional work machine, I can absolutely see how integrating a semantic search directly into your AI workspace could save hours of agonizing context switching. You just have to treat the tool with extreme vigilance regarding your data permissions.
That is exactly the right approach. Treat it as a highly powerful automation tool, but keep it on a very short, heavily monitored leash.
All right, before we wrap up our analysis today with a final look at the big picture, I want to drop one last quick reminder. If you are actually going to sit down and try that Gemini Canvas trick this weekend, or if you are planning to experiment with those local multi-agent workflows we discussed earlier, make sure you hit subscribe on the AI Verge channel. It ensures you have the practical, no-nonsense workflows you need to stay competitive next week.
We want our listeners building and experimenting, not just passively listening to the news.
Let's do the closing recap and pull all these threads together. If there is one macro takeaway from our deep dive today, it is that high-quality data and physical hardware are the ultimate unforgiving bottlenecks in this industry right now. Whether we are analyzing tech giants bidding millions of dollars in a bankruptcy court for a defunct airline's 1986 logistical chat logs, or we are looking at Nvidia forcing massive price hikes onto the market because the physical manufacturing of high-bandwidth memory chips is maxed out, the absolute physical and informational limits of artificial intelligence are being severely tested.
And those physical constraints are what is violently dictating the new software realities. The giants can't just buy their way to infinite scale anymore.
Which perfectly sets up the one major trend you need to watch moving forward. Watch how those extreme constraints are fueling the open source and small model rebellion. If anonymous, highly capable models like Ox Alpha can simply drop out of the sky for free, and if hyper-specialized, lightweight models like Savant 3.5 can reliably crush the trillion-dollar proprietary giants at specific, valuable business tasks, then the protective moat around frontier AI is evaporating much faster than anyone in Silicon Valley predicted.
The intelligence layer is rapidly becoming a commoditized utility. The ultimate winners in this next phase won't necessarily be the labs with the biggest hardware budgets. They will be the companies who know how to intelligently route tasks to the most efficient models.
Your weekend action item is simple. Don't just absorb this theory, execute on it. Take 15 minutes. Find a boring, chaotic Google Sheet and use Gemini Canvas to transform it into an interactive dashboard. Force yourself to interact with the technology.
And as always, manually audit the AI's data output before you trust it.
Always audit the data. So as we sign off, I want to leave you with a completely different angle to think about regarding these autonomous agents we've been discussing. If small, highly efficient AI agents are rapidly taking over our internal corporate systems, if they're the ones reading our emails, booking our meetings, managing our software pipelines, and negotiating our calendar times, what happens to the economy when a specialized AI agent acting on behalf of a vendor starts directly negotiating a digital contract with another specialized AI agent acting on behalf of a buyer, and human beings are entirely locked out of the loop? Are we building tools for ourselves, or are we building an invisible, high-speed shadow economy where humans are just the bystanders? Thanks for joining us for this deep dive. We will see you next week.